Okay, hello and welcome everybody. We're at the top of the hour. Good afternoon, good morning, depending on which part of the world you are. And welcome to this NAV Skills webinar. Today we have quite a number of registrations. We had 350 people registering for this webinar. So it kind of indicates how important this topic is. Today we have Vjekoslav Babic, Vjeko, as a presenter. We're going to talk about Azure Functions, invoking from VS Code. Before we hand the floor to Vjeko, I have a couple of housekeeping rules. The webinars, as always, are announced on our website. If you go to navskills.com/webinars, you can find a list of the next webinars. If you missed a webinar and you want to see the recording, you can go to our YouTube channel. We currently have 850 people subscribing to the YouTube, so it's a pretty efficient channel to share the webinars. If you have any questions, type your questions in the GoToMeeting questions window. I will be watching the questions. If I think the question is important enough to raise immediately, I will do so. Otherwise, I will wait with the question until Vjeko ends his presentation, and we'll keep 5 or 10 minutes at the end of the webinar to answer questions. Of course, thanks to Liberty Grove Software, we can actually host these webinars. As always, there is a call for content and speakers. Most of the time, I'm the one who thinks about the topics that I think are interesting, like this one with Vjeko. But we're always looking for someone that has something to share or something to present. The next webinars will be in September. Unfortunately, we scheduled 2 webinars in the same week because next week I was unavailable. The one that I wanted to highlight is the one with David Singleton. First of all, David was the first one to volunteer for a session, and I'm very happy that he did that. The second one is that David is going to introduce the history of NAV from a technical perspective. And for that, we actually need questions. We have a lot of people entering our channel as new developers, and those new developers have to deal with a lot of legacy code in NAV. And what David is going to do is he's going to go back to the DOS version 3, and from the DOS version he's going to explain what changes were made in NAV and why some things are the way they are. Like this piece of code where you're moving a parameter into a global variable and then calling a function called code, or when you use an integer variable in a report on a temporary data item. This is stuff that is not necessary anymore, but it's still in the legacy system, and I think it's important that people understand why. And for that reason, we actually need to know what questions you have. And we also are looking for a DOS version 3.04. If anyone has a Navision DOS version 3.04, please send me an email so we can actually show that version as well. Currently, we have to start at the last stable build of MS-DOS. That's all. With that, I'm going to change the presenter to Vjeko. Vjeko, you have the floor.
Thank you, Mark. I hope everybody can see my screen. Hello, everyone, and welcome to this webinar, which I called Azure Functions 101, which is, in fact, about invoking Azure Functions from AL. Something is wrong with my presentation. My name is Vjekoslav Babic, and I'm an MVP for NAV, and I'm a partner with Cloud-Ready Software. So I've actually, to deliver this webinar, I will have 2 parts. In the first parts, we will have some theory, which I will try to keep as little of theory as possible, and then the next part we will have some practice where I will in fact just go through a number of examples. I've prepared 10 groups of examples, which is not exactly just 10 different examples, but there will be a lot of code, most of which I will be building in front of you. So we will actually do quite a lot of dirty work here to get things done. So let's talk a little bit about Azure Functions in the first place. So what are Azure Functions? There are functionality of Azure application services which allow you to run small pieces, isolated pieces of code in the Azure cloud. Inside of those functions, the idea is that you as a developer actually focus on writing code rather than worrying about all other tasks which are normally revolving around development, which include infrastructure, configuring the Azure cloud, making sure that all deployments work, etc., etc. So with functions, you're actually just focusing on developing rather than anything else, and everything else is taken care by Azure infrastructure. And if you think of how you would normally publish services or service applications, they typically come with a lot of administrative chores. Here, with Azure Functions, they are kept to the minimum. And another very important aspect of Azure Functions is that they are supported in a number of different computer languages. So you are not constrained to only let's say C# or Visual Basic.NET as typical .NET languages. You can actually go forth and develop in a number of other languages of your choosing. So let's take a look at Azure Function features. So the first one, as I mentioned, is the choice of language. So you can develop your Azure Functions in C#, you can develop them in F#, you can use JavaScript, Python, PHP, etc. And Microsoft is going to add a number of functions as we go. You can expect that over time there will be more and more languages supported. So whatever your language of choice is, it's most likely that it will be there supported in Azure. Regarding costing, this is typically one of the first questions that people ask. Okay, if I want to use Azure, I have to think of how much it costs. Azure Functions come with a pay-per-use model, which is nearly free. So every Azure account gets 1 million invocations of Azure Functions per month. This is roughly 23 invocations per minute if you run full-time. So it is quite enough. And if you exceed that, the costs are not too much. I'm not going too much into costing. You just need to understand that for typical use cases, especially our NAV use cases, most likely it will just be free. Then another interesting feature of Azure Functions is that if you're using Visual Studio languages such as C# or F#, you are able to deploy dependencies. So you can specify external libraries, for example, from NuGet or from NPM, and actually bind to third-party libraries that you are using inside of your code. So you're not constrained just to native .NET stack. You're actually free to use any other library that is available anywhere. Then it comes with integrated security. It has actually two tiers where you can define security. First is authentication tier, where your application, or actually your Azure function, responds to requests which are authenticated either using built-in code authentication, or you can authenticate using OAuth authentication, which supports a number of providers such as Azure Active Directory, Facebook, Google, Twitter, Microsoft accounts, etc. We will talk a little bit more about authentication. We will just not go too deep into authorization because this is a complex area. We can discuss this in the Q&A. Then we have flexible development. You can develop Azure Functions either online in Azure Console, or you can develop them offline in your on your machine. You can use Visual Studio or Visual Studio Code. It integrates with Git, so whatever you publish to Git can automatically deploy to your Azure Function application, so it's very easy to actually develop for Azure Functions. And then probably the most interesting of all is that the entire Azure Functions framework is open source. So much the same way as Microsoft interacts with the community inside of the AL project, where they're building this AL compiler for Dynamics 365 for financials in Visual Studio Code, they are interacting with the community in Git inside of their project on Azure Functions. So Azure Functions is currently pretty much in development. There are bugs, there are issues, and you can go there and you can file issues. You can see actually how the project is going on and how it is developing. Let's take a look a little bit at the function architecture. What do functions comprise and how we actually build them? On the first level, we have a function application. The function application is in charge of the most important areas, such as configuring how it will behave, setting up security and authentication, defining service plans. It's in charge of resource management, of deployment automation, etc. To start with, Azure Functions, you first have to have a function application. And then once you have a function application, you can start creating your functions. And each of those functions is, in essence, isolated. So they do inherit settings from the application, but they have a number of settings and traits or metadata of their own. So each function comes with its own source code. Each function can be in its own language. So you can have one function application which runs functions in multiple languages. Each function has its own access keys. Functions are responding to triggers. So you define what is triggering Azure Functions. There are a number of different things, as we will see. Then we can define bindings. We can bind certain inputs and outputs to automate workflows with Azure Functions even further. And of course, we can monitor each of those functions. Let's take a look at how we can invoke Azure Functions. So there are, I have grouped them in three groups of triggers. And if you're following the Azure documentation, it may be grouped differently or just listed all of them in one group. I would like to call them these three different names. So first is Azure Triggers. Azure Triggers are events that happen inside of the Azure infrastructure, such as, for example, blob triggers or event hub triggers or storage queue triggers or service bus triggers. Using those triggers, you can actually automatically respond to certain events, like some data is being written or something is happening on a service bus, so you're reacting. Like this is especially targeting, for example, Internet of Things scenarios, etc. Then we have what I call other triggers, where we can define HTTP requests. This is typical. This is something that when you think of service-based architectures, this is what this HTTP request is. You're simply responding to an HTTP request. And then you can have a timer trigger, which allows you to specify a timer on which your Azure function will execute. And then finally we have hooks. There are two kinds of hooks. And in fact, first one is GitHub hooks, which means that you can subscribe to automatically run something whenever a GitHub webhook is invoked. And then you have generic webhooks. Whichever application supports webhooks, you can bind to it and respond to its events. Of course, you can also publish your own webhooks out of your Azure Functions, which means that other people who would want to hook into your workflow can easily do that. Why do we need Azure Functions? So here I have put three possible reasons why NAV people would want to think of or involve Azure Functions, put them inside of their development arsenal. So the first is probably integrating service workflows. When you have complex workflows where you want to offload certain functionality out of your application, then you can integrate with those service workflows. Here, primarily, I'm talking about service bus integration and similar. Another, probably more important area, because it is more readily usable and more versatile, is providing web APIs. The days of building APIs as monolithic DLLs or assemblies and then ship them as binaries to your consumers are over. So today, if you think of any functionality, it's more likely than not that you will find it as some kind of web API that you will be able to invoke using RESTful technologies. And this is where Azure Functions come nicely and handily in. You can build huge libraries of functionality for various different things, like image management, for example, to transform images, resize images, whatever else. And then you can either provide those APIs to your applications, talking about NAV, or you can sell them as a service to third parties who would want to consume them. And the last one, and definitely the most burning one for us NAV folks, is replacing .NET interoperability. So we are all aware that as far as Dynamics 365 for financials goes, we have no .NET interoperability. So you cannot declare a .NET variable. If you do that, you are not able to compile your AL code. And this is something that is not going to change. So at least this is what Microsoft says. And knowing everything, the reasons why Microsoft has decided to forbid access to .NET interoperability, it is definitely very unlikely that this decision will change. So in front of us, we have this huge world of no .NET. So we have to figure out how to refactor our code, which has been there for now already 7 or maybe even 8 years for some people, that is running in .NET Tier, which we cannot use anymore. And I'm pretty sure, and I'm talking from my experience, there is quite a lot of it. There is quite a lot of .NET. It was blogged about, books have been written about it, and it's not there anymore. They're saying that the fact that we don't have .NET anymore is actually very good. If you think of the pains of maintaining .NET interoperability with your NAV, it was really huge. So if you think of maintaining a .NET library, if you change something in your .NET library, the minimum of administrative tasks you have is to restart, or actually stop your service tier, deploy your new binaries, and then restart service tier. Because if you don't do that, your AL code will not have access to the newest version. That's at minimum, and that's if you are actually doing dirty work. If you want to do it clean, then you would have to increase your version number, and increasing version number is actually a very breaking change for CL, because then you have to change all of references inside all of your code. So if you had one library which was big, and then you wanted to up version that library, you potentially had hours of work in front of you to properly refactor all that to actually reference the new version, and then recompile all of NAV objects, and then deploy all of NAV objects, including your new version of assembly. So it was quite a lot of work to be able to have this .NET luxury, so to say. Now without that, we have Azure Functions, or we can actually use Azure Functions to replace .NET interoperability. We do not need to restart anything. We don't need to restart NAV. We do not need to rebuild anything. So these are pretty much detached as much as possible. So this is very loosely bound, this NAV end and Azure end. So that was theory. Let's talk. Let's actually jump right into the practice, and let's go into Visual Studio Code. So I'm pretty sure that all of you are familiar with this screen. I'm inside of a Visual Studio Code application. I have actually prepared a very simple application. It does nothing. I will just run it, and when it runs, it simply loads a page. And this page has an on-open page trigger, which runs this code unit. This is the simplest. It was actually the most simplest way for me to make this demo work, because everything else was unreliable. You may be aware that there are bugs inside of beta versions of Dynamics 365 for financials. And that sometimes you just don't see elements on pages that you have added to pages. And with this demo machine, I've hit into that problem, and I just cannot see anything. So I had to fall back to actually just doing stuff from the on-run trigger. So there is no magic in there. There is this page which shows nothing, and then it calls this code unit, and then whatever this code unit has inside of it, it shows. So let me just do one more. And let me run this just to show that this is not smoke and mirrors. It is just this application running. The first thing that I will do after I show that this is really all working fine is actually to create an Azure function. So let's take a look at, actually, let me just go back to my dashboard. First thing that you want to do is you want to create a new function application. So you would click New, and then inside here, you would have to search for function apps. So it will show up in the search results, or if you have created one recently, you can just click this Create, which is going to be among your most recently used Azure functionalities. So you have to give it a unique name. So I will call this Azure Functions from AL Demo. And then it shows me that this is a good name. It is not used already. Then I choose my subscription. I need to create or choose existing resource group. I will just create a new one. I will choose consumption plan. It can have app service plan if you're 1 million per month free and then others are paid. Plan does not work for you. You can bind it into an app service plan and then have it built according to your app billing rules. Then I will choose location North Europe because I think this is closest to me. And then I will just create a new storage group. So when I click Create, this is going to start the deployment of my new function app. And within a minute or maybe even less, I will have my new function app deployed. So I can click here and I can see that deployment is in progress. And then, in fact, I can start preparing to look for that app. As soon as it's prepared, I can see where it is. So once you have created an app, to find that app, you would go to More Services, and then you would search for function apps. One good idea is to actually favorite that function apps, and then I will just drag it on top because this is currently most important for me. So I will click this function apps here, and I will see the list of all of function apps that have been deployed to my account. So right now this deployment is still in progress, so I will let it run to completion. And in the meanwhile, I can actually use one of those function apps that I have built or created earlier. So here I have this Azure from AL demo, which has no functions in there. Actually, sorry, let me just go back and use this new function app which has just been created. So here I have Azure Functions from AL demo. I will click that app and I will see that it contains nothing. So it is currently in the running state and it has no functions. So let's start by creating a new function inside of this app. So I will click this plus button next to the functions node, and then I have a choice whether I want to create a new function from scratch, which is not exactly from scratch, or I want to use a pre-made scenario template. So let's just start with this webhook plus API in C# language and just click create this function to show to you how easy it is to start with Azure Functions. So I will click create this function, and then immediately I get a function which receives a parameter of type called name and then responds with hello name. This is just a typical hello world example. So we'll get this function URL, I will copy this URL, and then I will actually just use my Edge browser to load this function. Okay, it tells me please pass a name on the query string. So I will just say, okay, name is Vieco, and it says hello Vieco. That's how easy it is to actually get an app, function app up and running. So the next step for me is, of course, to invoke it from AL. So let's do some AL code to invoke this Azure function and make it work from within here. So invoking Azure Functions from AL is very simple because one of the things that Microsoft has done to help us replacing our .NET interop code is to simplify invoking of web services. And since this Azure function app, which has an HTTP trigger in the background, is nothing but a web service or a RESTful web service, it's very easy to invoke it. So we'll just do a new local procedure and invoke Azure function. And I will start with having one variable, which I will call client, which will be of type HTTP client. And then I will simply start client.get, and then here I will paste the URL of my app. And here I will add name is Vieco. And there is one more parameter that this client get receives, which is response, which is HTTP response message, and I will pass that one in here, so I will get this response. And then I need one more variable which will be of type text. I will call it result which is of type text, and then I will do response content read as, and then I will read, sorry, result as text, and simply do message and then result. And of course, from within my on-run trigger, I will invoke Azure function, and that's it. So when I run this, it will immediately go into my Azure function. It will run it, and you will see how fast it actually is. It is in essence immediate, especially if you're using the same resource group. You will just not perceive much downtime. So that's it. That's all you need to be able to quickly and easily invoke an Azure function. Let's take a look at some other settings. What can we do with those functions? This is just a very simple one. Of course, during this webinar, we will go and build more complex examples. Let's first take a look at this integrate node, what we have inside of there. So here we have some settings about my function, like what is triggering it, and I have some bindings for inputs and outputs. I will leave those alone, and then I will change a couple of settings. First, I do not want this function to respond to everything. I will simply go and make it respond to only post kind of request. And then I will make it anonymous. So I will just make it a little bit simpler to invoke this function. I will save that. It will apply immediately. So when I run my function from AL, I will see some change. So I'm now running this, and when this runs, I will see that I get an empty response. So what does this empty response mean? It in fact means that something probably has gone wrong. And of course, to see what has gone wrong, I have to inspect certain things. You can see that this is not an error. I didn't get an error. I simply get a response which I may not understand properly. So let's take a look at the first thing. This is HTTP. And in HTTP, you have requests and responses. And unless something goes very badly wrong, like your network is down or you are calling a non-existing host, then you will always get a response to your request. And even if there was an error, you will still get a response. You will not just get an error. So this response has a status code. So the first thing that I will do here is I will actually show the response and then HTTP status code to see what happened. What was the status code that has happened? Why is this not showing anything to me? So when I run this now, when my NAV page loads, I will see that it says 404. You may know that 404 means not found. So apparently the resource that I called was not found. And why was it not found? It wasn't found because I have made a post request. So this post request means that I have to call post method, and in fact I have been calling it with the get method. So let's change the infrastructure of this function by allowing to respond to only get requests. So when I do this now, if I stop my application and then run my application again, so at this stage it will still not work. There is something else. So at this stage, it tells me 401. 401 stands for unauthorized. It says that it's unauthorized because it's actually over-authorized. I'm attempting to authorize on a function which does not have any authorization on it. So I would have to remove this code from here. So I'm just going to remove this code part. And then I will run this function again. And then I will see that in fact it works. So depending on what you want to do with your Azure function and how you want it to respond, how you want to pass data into the function, you may want to make it respond to get, you may want to have it respond to post, but you should control how it is being invoked. Having it at all method setting will make it more complicated for you to develop that, because inside of your function you may need to test for query strings, you may need to test for body of the message if you have posted. Let's take a look. So here, if I click my function, which is by default called HTTP trigger C#, you can see that it is actually reading a query parameter, meaning I can pass a query string. But it's also reading the body, which means I probably posted something to my Azure function, which means that I'm supporting a fallback. If this is get, do this. If this is post, do that. And this is not how you should work. Your functions should be very specific. They should respond to specific requests. So in fact, next thing I do, I want to change this to post request. This is more common because you can pass more data, and you can pass more, let's say, strongly typed data using post requests. So I will just save this function to accept only post requests. And if you remember, if I don't call post, this will now fail. So I will have to change my my Azure function code to involve post. So I will simply copy this, and I will call it post, and I will invoke this post. So it's not as simple as just replacing this to post, because when you are posting, you have to pass the content. So I need another variable of type HTTP content, where I will simply put this content here, and then I'm calling this post method. So when I stop this function now, and when I run my application, it will now work again. So now it has actually responded to the post request. It didn't return 404, and then it has read my data from the query string. Typically, when you are doing post, you're not passing data using query string. So what I will do here is I will remove this from the query string. So I don't want to post and send query string at the same time. I just want to post data. So if I attempt to run this now, it will not work because there is nothing to read. If you take a look at the function itself, at the function body, it will be null because it's not a query string parameter and it's not a body parameter. So both of them are null, so it says please pass a name on the query string or in the request body. So I have to somehow put this parameter into the body. So let me do that. I will just do content, and then I will do write from, sorry. And then I will just put the echo in here. So if you expect this to fail, you are right, this will fail, but let's take a look at how it fails. So I'm running this now, and let's see what happens. Okay, so now it's failing with something very, very bad. So it's failing because I did not pass the content as expected. If you take a look at the body of the function, it says that it wants to read it as dynamic object, which means there will be some serialization involved, and it cannot serialize for a number of reasons. There is one big reason here, because I'm just passing plain text. It cannot serialize plain text. And then if it attempts to, and even if this would succeed, it's trying to access the name property of whatever this object is, and I didn't specify any metadata in here. It is just a string value. So this will just not work. So I will have to fix that, and I will fix that a little bit later. Let's, in fact, talk about the next thing which is important when talking about Azure Functions. It's error handling. So you might have noticed that while I was writing code, I didn't attempt to catch any errors. I didn't do anything specifically to prevent bad situations from happening, but this is not how you would normally write code. Normally, you would put some error handling in place. So let's do some error handling in here. First thing that I will do, I will just switch this quickly back to get. So I will allow get only, and I will save that. And then I will just for now comment this, and I will do, sorry, I will do it like this, and then just like this. So first thing is this get and post and other HTTP methods, they can return Boolean. So if you take a look, they come with this very known CL pattern, where if you invoke a function without inspecting the result value, it will fail if there is an error. But if you invoke it with if, then you have a chance to actually capture that error. So I will do if not client get, then, and then I will do error, something went wrong. So this is not a very informative error, but you know, users never actually read those errors anyway. So let's try to see what happens if I do it like this. So I will just do this error, something went wrong, and then I'm going to read the response content, and then I'm just going to run this demo again. So currently it tells me please pass a name on the query string. So it didn't actually fail. It actually went through all the way. So this get did return something good. So to actually make it fail, I would have to do something very bad, like changing the URL. So let's take a look what happens if I change the URL. Then I will get actually this something went wrong error. But in this example that I've just shown, it has went through and it has actually shown to me that I have got a 400 error, and then it told me that I need to do something else. So now it tells me something went wrong. So this is for really bad errors. What I can do instead of this is I can do or not, and then client dot response dot is success status code. So here I'm saying either if the client get fails because, for example, I have a very wrong URL, or if it fails for an incorrect status code, just show me this failure. So I will just stop that and I will run that, and now I will see that it's actually failing, and it's always failing with this something went wrong. So this is how you can establish certain error catching frameworks inside of your CL. You should inspect this. Sorry, I will just close those pages. You need to inspect the is success status code of the response variable, and you need to inspect the Boolean outcome of your get, post, or other HTTP methods. So this is how you would normally handle errors. So you would put some pattern like that. You would probably want to log the errors. You would still want perhaps to read the content of your response, but for now, just for this demo, it is not that important. So let's take a look at some other examples. I'm going to put post back in here, and then I'm going to put my post code, if not client post, and then I will just remove this part. So I'm posting the data in here, and so now I will run my code again. And here I will see that it will still fail with something went wrong error, because it has captured the issue that was returned by the service tier, and you should not go and do your standard logic, which would happen on success. You need to somehow exit or inform the user or log the error or whatever else inside the in case there is either false or is success status code is false in here. So you have seen so far that you can in fact handle errors, and you should handle errors, but let's take a look at why exactly did this fail now. I have passed the data into my Azure function, and it still didn't read it. It has returned some very strange error, if you remember the exact error text. So let's talk about monitoring. Azure functions come with monitoring facilities where each function can be monitored by clicking on monitor node, and then you can see the list of all invocations. So here, all of those invocations will be listed. Sometimes it takes time, and sometimes even after a little time, it may not show anything. So you can monitor your invocations from here, or you can monitor your invocations from the Azure Functions URL. So I will open Azure Functions URL, and then I will go to Kudu site for this. So just put SCM in here. And now I'm inside of the Kudu site. This exists for all of Azure service applications. And then I will go to Tools, Web Jobs Dashboard. And then I will, when I'm inside of Web Jobs Dashboard, I will just click Functions. And then, well, it's taking a little while to wake up. I will click Functions, and then I will have my functions, and I will have invocation log. If I have multiple functions, I can click whichever function I'm interested in, and then I can click the function execution and see what went wrong. And if I click this toggle output, it will actually show to me that there was some runtime error inside of this specific invocation. If I take a look at this successful invocation, I can see that this one has actually succeeded. So this one has logged this success request, which I can see in here. The first thing that I do from within the function is this log info, where I log the successful invocation of the function. So apparently it would be very good if I could somehow debug these functions, because there was a runtime error. I want to see what exactly is wrong. So can I debug my Azure Functions? In fact, yes, I can. So there are two ways of debugging. One is remote debugging and one is local debugging. I will first show you how to remote debug. So I will simply go into my Visual Studio 2017. Just one hint, if you're using this version of Visual Studio, then you will have to have update 3 with all of Azure components updated. So I will go to Cloud Explorer, and then I will find my subscription. I will click Apply, and then I will take a look at my app services. I will refresh that because it shows some old state from earlier. I will go to App Services, and then I will look at my Azure Functions from AL Demo, and in here I will see that I have some files. I can see here that I have this CS6 file, which run CS6 file inside of my function folder, and this is my function body. Whatever I see in here is exactly the same thing that I see in here. In fact, here you can see that it shows syntax highlighting. I will close my Visual Studio for now. I will not save anything, and I will just start it again and show you what happens if you do that for the first time inside of Visual Studio. So I will just go to Cloud Explorer. I will quickly open that Azure function. Just a second, it has to refresh the resources. So App Services once again, and then Azure Functions from AL Demo, and then I will click Files, and then HTTP CSharp. It's taking a while. And then run CS6. You will see in here that it actually doesn't show syntax highlighting, but it still allows you to set a breakpoint. So if I select this line and press F9, there will be a breakpoint. And I can in fact just right-click my function application, and I can click Attach Debugger. And at that state I'm actually connecting to my Azure app service, my function app, and it is establishing all the necessary endpoints for my debugging at the remote end. First time that you do, it might take a little while, like a minute or two, but next time that you do, it will actually be instant, so it will immediately bind to this this function. When you do that, okay, so now it's finding the process to attach, so it will go through multiple statuses. When you do that, whenever you invoke your function from wherever, your breakpoint will be hit in here. So it's now telling me that it's taking a little longer than usual. It's not a problem per se. So let's wait a little bit. I think it has now found it. So at this stage, it is, I think, ready. Yep. So it's loading my Azure Functions site to tell me that it's now ready for debugging. And at this stage, I can go back inside of my Azure Function AL demo, and I can invoke it. Let's take a look at here. So it's now loading symbols. It will be quick. Okay, good. I will now run my Azure function. So it will open NAV, and then in the background I will be able to see that my my breakpoint will be hit. So I'm running NAV, and then here it stops my breakpoint. So inside of this debugger window, I can see the line where I am on, but I can't inspect anything. I can't see whatever is going on. I can just run and see that something went wrong, and I can try to do that again, and then it will again stop. Sorry, I will have to run it again. And I will see that I'm, in fact, stopping on a breakpoint. I can see my call stack, and I can actually step through. I can see that it is actually failing at this line. So here it's telling me something is wrong, something is bad, and I need to do something about this line to actually fix that. As you can see, this is not too useful because it's not showing any syntax highlighting. It doesn't show you any kind of watches or inspection functionality to see the values of your variables. So for that, you would actually, I think this is a bug in Azure Tools for Visual Studio, but if you just start, like you create a new C# project of any type, like you can create a simple console app. Once you create that and you open your Azure function, it will actually load all the C# syntax highlighting, and then when you actually set a breakpoint and then right-click and say attach debugger, it will now be much faster. You will be able to see that when I run my NAV, it will stop on the same breakpoint and show me some more information about what's going on. So let's take a look. It's still building the app, still not running it. This is not that instance. Now I will stop that. This happens sometimes, that you just have to stop this function service, and then yeah, this happens. I will just have to start this again. Sorry, I will have to start this again without debugger in there. This is the problem of Visual Studio. So sometimes it happens that when you try to debug, it doesn't do anything. So your NAV will seem as if it's stalling, but it's not. In fact, it's working, so I will have to run it once without debugger and then once with debugger. So now it's going to reattach, and then I will run it again. So when I run it again from here, sorry, I have to stop this first and then run it again. Let's take a look. Okay, it's running, and then it's stopping here on my breakpoint, and now I will have the entire inspection available, so I will be able to see what this log is. I will be able to inspect in there. I will have my locals. I will be able to add some more watches, and then when I step through, I will be able to see here when it fails again on which line it failed, and then I can explore my failure here. So the problem, in fact, with this failure is that I'm trying to deserialize data which cannot be deserialized. So instead of simply debugging here, I can also change code from my Visual Studio. So I can do string, and then I can do content read as string async, and then I will remove that. And then I will just do this. And then I will simply save. So when I save this, it will save inside of my Azure function. I will set my breakpoint here. Then I will attach the debugger. So it will now attach. Since I have changed my code, now at this stage it has to recompile that. Once it recompiles, it starts my Azure function, and then I'm ready to invoke that. I will run NAV again, and then when it runs, I will be able to see that it stops on the breakpoint. Okay, and I can step through. This works. This now works. I can see that data is actually, I need to refresh that. Well, it doesn't. Yeah, it doesn't show me the value of data. But here, if I inspect this, now I can see that the name is Vieco. Of course, it didn't show me because it was an async operation. And then I will proceed with executing, and it now returns this success code, tells me, hello, Vieco. You can see that developing directly in Azure is not the most efficient thing. So developing like that is not efficient for multiple reasons. First, you can see how this debugging is clumsy. Every time you have to debug, you have to attach, you have to fight with this syntax highlighting and everything. And then on top of that, I could have easily done something like retained this .name. I could save this now. And if I run my function again from within NAV, it will fail, and you will not know why it failed. You will have to go and monitor and inspect why is it failing, what's actually wrong with this function, because here, when I invoke it, it tells me something went wrong. And the fact that something went, I know what went wrong. This is string, and string does not have .name, and Visual Studio is not complaining. So here, if you do that, when you're developing Azure Functions inside of Visual Studio, you have absolutely no compiler or integrated compiler that tells you if something is wrong or not. So developing Azure Functions inside of Visual Studio is much better if you don't do it remotely, if you actually do it locally. So let me do that. Let me actually close this Cloud Explorer and close this solution that I have. And then let me start with a local solution for Azure Functions, which will allow me to develop functions locally and then publish them or deploy them to Azure when I'm happy with them. So I will start with a new project. I will choose Cloud, and then I will choose Azure Functions. For this, you absolutely have to have Visual Studio 2017 and all the latest Azure development components. And then when you select Azure Function, I will call it in Azure Functions from local dev. And I will just click OK. This creates a blank Azure Functions project. It doesn't contain anything. It doesn't contain any functions. And then I have to create my functions manually. So let me start and create a first Azure function. So I will just create a new item. I will select Azure function, and then I will call it invoke simple.cs. You see that here I don't have CSX, which is C# script. I actually have C#, full C# language. So I will have to specify what kind of trigger I want. To invoke from NAV, you need to have HTTP trigger. And then access rights, I will make this anonymous, and I will click OK. So at this stage, I have this invoke simple, which is nothing but my but same function that I used to have, which is just hello world function that contains some very simple code. When I press run, what it in fact does, it runs off my local machine. It simulates Azure application service environment, and I can test and debug and do everything locally. So let me actually take this URL here. I will copy it. Then I will go in my example here. I will exchange my Azure source code with my local function URL. And then I will invoke this one. Okay. And then, of course, I will set a breakpoint on this line. And then I will press F5 to run. And then you will see that it is much better because it's integrating locally. It shows me everything locally. I can just do whatever functionality I want. It has full syntax highlighting. It completely understands what's going on. it now has full inspection capabilities. I can even change this to Mark, in case Mark is still listening, and then I can run, and then I can see that my NAV will say hello Mark, because this is entirely running locally and simulating Azure environment. So this is the best way, this is the preferable way of running development tasks. Simply create an Azure function project locally. You can then integrate that with source control. You can even automate source control deployment so that whenever you check in a Git repository, it automatically pulls everything from Git repository into your Azure function application and does a build task, and then immediately, as soon as you have published or actually synced your Git repositories, it will automatically update your Azure function, rebuild and restart everything, so you have the fresh version. This is the best way how to actually maintain those Azure functions. One important thing is when calling Azure functions, you are typically you will very rarely pass some simple data. Like here I have passed a query string, which is called vieco, which is a very simple thing to do. Instead of that, you may want to pass some more complex data. For example, you may want to pass JSON data. So let's take a look at how we can actually pass JSON data from, in fact, from this URL. I will just replace my post URL. I will remove that, and in fact I will want to post this vieco. If you remember, this will fail, so we'll just do post. I can now get rid of this first function because I don't really need that anymore. I will just focus on this function that will handle JSON. For now it has no JSON, it is just plain text. So if I run my application in here and then run my NAV application here, let me try to capture this problem first. So when it runs, it will actually stop here, and I will see that it's failing here because it cannot read this. It cannot read value vieco from my body of my request. So let me just actually pass the real JSON inside. So I will go in there and I will change this into some real JSON. So I will do name vieco. So this is real JSON. If I attempt to run my my function app, and if I attempt to run my NAV, of course, breakpoint is still here. Let's take a look at what happens. So I'm attempting, in fact, to pass a real JSON string, which now my application should be able to understand. Azure Functions do understand JSON natively, but still it will fail at this line because it cannot deserialize this JSON. And why cannot it deserialize? Because the content type of my function is, in fact, wrong. So I would have to change the content type. I will rerun my function, and I will change the content. Yes, Mark?
This is really amazing stuff, and I don't know how far you are on your 10 demos.
I'm pretty close. This is the last.
Okay, so let's finish this one, and then we'll do Q&A. It means that for everyone who is attending, we will run a little bit over the top of the hour. If you have to leave, then so be it, but you can actually listen to the YouTube recording if you want to listen to the Q&A.
Thank you, Mark. Okay, I will be quick. So this is the last demo. So I will go in my heading, my variable declaration, and I will create another one which is called headers, and it will be of HTTP headers type. So the reason is that whenever you're passing content to HTTP requests, you have to specify what is the content type. And content type has to match whatever the application is expecting. If you don't specify it, it's just plain text. And JSON is not the same as plain text, even though it looks like plain text. So first thing I would have to do, client.get, content.get headers, and then I will receive it in my headers variable. And then first I will have to remove my content type header. And then I will add content type again and specify that this is application /JSON. And when I do that, when I write the content, it will be in JSON format. So when I invoke my Azure function, it will in fact read this as JSON and respond as whatever the response here is. So here I can see that it is now able to deserialize this JSON. So if I take a look, this data.name is now Vieco, and when I receive my message here, is going to say this is hello Vieco. Of course, if you want to send JSON out of your Azure function, it's also possible. I will have an example on my blog, but in the meanwhile, you can see how AL code is handling such JSON which comes out of HTTP requests or web services or Azure functions. You can read these two excellent blog posts by Arendjan Kaufman, where AJ has actually explained how handling JSON on receiving end actually works. So we are really short on time, and I wanted to show certain things. So part of this demo, the last part, is once I have my Azure function, how do I actually put it in Azure? Because this is now running locally. You would simply right-click your Azure function project, you would click Publish, and then you would specify which publish settings you are using. You can either create new publish settings, or you can select existing publish settings. Then you would click Publish, and then you would have to specify which subscription you are using, which resource group you are using. Here, it's now going to refresh my resource groups. It's going to show my all of my applications. So here, I may want to deploy to this Azure Functions from AL demo. I can select this and click OK, and then it will prepare my publish profile. In a minute or two, this publish button will be ready. When I click Publish, the function goes into Azure, and you can invoke it from Azure exactly in the same way as you would invoke it earlier. I don't have to show that. Take my word for that. So this was all that I have prepared. This is a huge area. Maybe I can discuss with Mark to have an advanced version of this webinar where we would go into more examples, like how to integrate this with source control. It could be a webinar of its own. Then perhaps we could talk about how to handle authorization, how to handle authentication, or perhaps how to handle specific scenarios such as passing binary data or passing XML data, or perhaps how to handle persisting storage inside of Azure Functions, like for retaining state between different calls. So the story does not end here. There is some information on my blog, and there will be much more information in there in the coming days. So thank you for watching, and let's discuss the questions.
Okay, thanks Vieco for this really interesting hour. I know Arendjan is actually attending the webinar as well, and I already talked to Arendjan about doing a webinar specifically about web services in AL with Visual Studio Code.
Perfect.
And for sure, I think we should follow up on this one with the next webinar. So we have currently 2 questions in the question window, but we are getting more, so that's good. The first question is, I think you can talk about this for an hour as well.
Can I see the question? I can't see the question. How do I see the question?
No, I will actually. I will read it to you. It's say,
okay,
Can you reference your own DLLs? And
of course.
I think in the context of that question, so let's say I have a current DLL that I have in a traditional way. How do I move my CSharp stuff to Azure Functions?
So first, what you would have to do is you would have to build a NuGet package out of it, because this is in the current iteration. It has to be NuGet. And then when you are in your function app, you would go and you would click Manage NuGet Packages. And then you would go browse, and then you would find your NuGet package, and then you would get it here. That's one way. The second way is, of course, you would have to simply take all of your C# code that you have. You can create, for example, you can say add a new folder, and you can call it legacy. And then in here, what you can do is you can add more classes, and then just have regular classes and put all of your C# classes and make them a part of your Azure Functions. You can have as many of them as you want. It is just a normal C# project, and all the code that you have built in there or made a part of this solution would be pushed to Azure and would be usable by the Azure function.
Okay. The next question is there something like an app store for Azure App Functions? So let's say that you have created something that takes a substring out of a string, which is a silly example, and someone else wants to use it. How do you handle that?
Well, that's a good question. I don't know the answer to this one. As far as I know, there is no marketplace for Azure Functions specifically, but I assume that you could make it a part of Azure Marketplace and try selling it from Azure Marketplace anyway. So maybe that would be how you would handle that. But again, as I said, I don't really know because I've never done that and I've never seen that. Keep in mind, Azure Functions are heavily in development, so this is going to change. Things that you do today will work tomorrow, but it's going to be improved, and maybe perhaps at some point there will be a specific API marketplace where you will be able to access third-party APIs and functions that are built by other people.
Okay. So the next question is, does AL support serialization and deserialization of JSON and automatic mapping to objects?
No, so you cannot, because there are no objects in CL anymore. That's something that worked out of the box earlier. You could serialize and deserialize JSON using .NET, and that worked like the charm, but currently you cannot do that. So when you receive JSON, or when you send JSON, you have to build your JSON manually in the current iteration. Sending JSON is more difficult because you really need to build it up from scratch yourself as a string. You can use a string, or sorry, text builder type, which is new type in August release of AL, or you have just to create it manually. On the receiving end, it's a little bit simpler because you can use JSON functions. I would again refer to Arendjan's post, which is called AL support for REST web services. Arendjan has a couple of good examples there how to handle JSON when received out of your Azure function. So then you have JSON object and JSON token and JSON value and JSON array types which help you automate JSON management, but still you have no direct deserialization into something that NAV natively understands. There was a discussion with Microsoft and there was a suggestion, and as far as I know it's a part of their backlog, that we will have a possibility to use either XML ports or JSON ports or something like that to map data structures in NAV to JSON structures and then serialize or deserialize from or to those structures, meaning that you would end up having NAV data model that you map to JSON, and then you can either send that or receive that. That would be beautiful, because then you don't have to invent any kind of objects in NAV, and you can still handle whatever data you expect to receive. So this is how it will most likely be handled in the long run.
Okay. So then we have endorsement to do version 2 of the webinar, or step 2. So
perfect. Thank you. I will propose a date to Mark, and then we will see when it can be scheduled.
Yeah. And then is using Azure Functions for processing sensitive data a good idea? So how secure is it?
Well, it is as secure as HTTPS gets. So if you take a look at, again, Azure Function, you can see that you can manage application settings. So you can go to platform features and then you can handle authentication and authorization. Here you can handle the keys, and then you can handle SSL. You can upload your own certificates if you don't trust the built-in certificates. So it is secure. So it's not any less secure than any SSL-based security is anywhere else on the internet. So if you don't trust that, if you still think it is not secure enough, then I would assume that you would have to invent something else, maybe some additional layer on top of Azure Functions where data is additionally encrypted using whatever other authentication, encryption method, but this is as far as it gets. So it is as secure as HTTPS, which is probably how your banking software works and how your mail works, etc. So it's secure enough.
And I would assume that also all the legal requirements about using cloud storage would apply, depending on your country.
Well, that's something I can't answer because
No.
I assume this is a question for Microsoft. I don't know what those rules are, but this is, you know, the functions are stored in your storage account, and all the logs are stored in your storage account. So yes, I don't know what kind of data, whatever kind of data you store, I think it's your responsibility to make sure that it conforms to regulatory requirements of whatever geography you're running in.
Yeah. So I have one more question, which is mine, and then we have answered all the questions from the question window. So if you have any more questions, you can actually type it during my question. What's the competition for this vehicle? I mean, this is from Microsoft, but what if you want to use something else? Does Amazon or Google have anything that like remotely competes to this, or?
There are competition. There are a number of competitors, even though I don't know any of them by heart. I forgot the name of. I've stumbled upon one, but I can look it up for the next time, or maybe you can just Google up yourself. There is competition. This is not the only way to run your chunks of code as a service. So this is just Azure. So I would say this is most advanced, this is most versatile of all, because it gives you the choice of languages. You can do JavaScript, you can do Python, you can do Bash. I mean,
yeah,
it's something
and of course,
kind of
and as a Microsoft partner, it's the obvious choice. That's what I would guess.
I would say it is, because every partner has Azure anyway, and then within your allowance, you can easily run a function app with a lot of invocations. And yeah, so it's really not that expensive. I don't think why you would want to look elsewhere, but yeah, there are competitors.
So let's take a question from our good friend Peter Thijsma. Peter,
Hi, Peter.
how easy is it to pass complex data like a picture into an Azure function? I mean, with JSON you can pass JSON like flat text.
It's easy. What you would have to do in that case, you would simply have to change this content type to application binary or whatever, or image, JPEG, or whatever other type. That's one thing. And then if you take a look at this right from, it in fact receives stream. So you have two overloads here, where one is in stream. So if you have your data in a stream, which is, for example, blob in NAV, you can pass it directly into your content. So yes, you can pass binary data of any type. You just have to worry or take care that your content type is correct. Otherwise, your receiving end might have issues with properly processing that.
And can you only have one content type per call, or?
Yes, you can have one content per call. So,
okay.
I mean, you could probably do something like make a JSON array with multiple elements inside of a content, but then you would have to base64 encode that. I know that Arangan has blogged about that as well.
Oh, yeah.
But it's I wouldn't go there. I would rather have, like, if you want to have multiple contents, then maybe you should have your bigger structure serialized into a bigger stream, and then I don't know. I wouldn't do that, but if you have to, there are ways. You certainly can somehow pack multiple things. Yeah.
And then we have a comment from Todd Scott, who is saying that Amazon AWS Lambda is a competitor. So
yeah, thanks, Todd. Yeah, this is good information. There are more. There are open source competitors as well. If you can call open source competitors, there are.
You can host your own, of course.
Of course, you can host your own, but then you have to worry about infrastructure and all. I think that Azure has done pretty beautiful job at, especially when you see how it integrates with Visual Studio, with Git. Like you can easily, maybe we can really have a webinar about that, how to integrate that with source control, and then you can automate tasks. Like you can have multiple different deployment kinds that you can deploy staging and deploy production, and then when you check in, it goes into staging, and then you can have all sorts of workflows that are fully automated based on just your commit actions from Visual Studio. So it really integrates nicely with development environments. I wouldn't really look into competitors far, or especially hosting yourself. This makes no sense when you take a look at how easy it is to host it in Azure.
Okay. So I think with that we have to close. As I mentioned earlier, this will be available on YouTube, probably later today or early tomorrow. Thanks again, Vjeko, for hosting this.
Great presentation.
Thank you, Arjan.
Yeah, and looking forward to seeing everyone again in the next webinar.
Thank you all.
Okay,
bye. Bye-bye.
Bye-bye.